Okay, I'll move on then. So our today's major use case is basically to make sure that we'll be working on credit card fraud detection data. So I have made a Jupyter notebook. Rather, I have just take a data set from Kaggle for credit card fraud transaction and analyzed it using application algorithms. I'll be going through all of them and I'll be explaining what are we doing. But before I actually move on, I want to tell how exactly to go about a machine learning task. That is a very important thing because see, every organization will not be paying you for just telling them, boss, these are the algorithms, out of these, this one works, this one doesn't work. It's really not the case scenario how this happens, right? So first of all, I need to tell the organization what insights you can obtain from a data. So the most important thing which I keep on focusing, which any of your online MOOCs or any other courses don't teach, is what do we ask? What are the correct set of questions we really need to ask as a data analyst or as a data scientist or as a business analyst also? I really need to day-to-day life in data observe patterns and I need to ask my client, what exactly do you want out of it? If you really can't tell that, then there is no point of making machine learning models or doing anything. So it's a fact that 80% of the time business analysts and data analysts today spend on cleaning data, obtaining major features and patterns. And this process of obtaining those major feature and patterns is something called data mining. And it is the crux or the essence of our machine learning today. So before we move on to the data, which has different columns, I'll be describing the data in the notebook. These are the three major questions which we can actually ask from a very user point of view, right? At the end of the day, when you're making a model in machine learning, it is supposed to be used by your users, your clients. So your clients won't be understanding that technicality. They just want answer for their questions. And these are the questions which they pose. So the first question for a credit card fraud detection might be, what time does the credit card fraud usually take place? Is there some sort of pattern in it? For example, do people prefer to have a fixed timeline? Say I'll commit a fraud at 8 p.m. or I'll commit a fraud in the early morning. Is there any certain pattern to it or not? We'll be answering these questions in our analysis. Second is, what are the general trends of amount for credit card fraud transactions? Are those very large amounts? Are those very short amounts? Are those very medium range amounts so that it actually goes unseen by the bank? Thirdly, how do we balance the data to not let the model overfit on legitimate transaction? Now it has different keywords into it. And these keywords are something which are very important. I'll be explaining each and every one of them exactly. So how do we balance? Balance means we make equal, right? The data to not let model overfit. Overfit means the model learns something consecutively. For example, if I'm fetching 10,000 legitimate transaction, automatically the model will start saying that the 10,001 transaction which will be in the input is also a legitimate transaction. But there is an equal probability for that particular transaction to be fraud as well. So that becomes a problem, like we need to handle it. So this is the major crux. So the first two doubts, a question which I posed, that was intentional. Those are the business doubts. When you are in an organization, you'll be answering daily as a data scientist to MBA people. And sometimes it's a good thing your MBA might actually answer you perfectly. But in my internship experience, I will tell it's really never the case. There might be some cases where you feel that your manager is very illogical. At the same time, he also makes more sense than you because he's able to see a business insight which you are not able to and relate to just because you are not able to technically implement the same thing, right? So at the end of the day, the business side cares about the first two questions. And the third question is also intentionally I put, that is towards more of a technical side. So we'll be covering all these three aspects and I'll be starting to share my other screen now. Just a second. Yeah, so I just switched screen. Is it visible to everyone? Just answer in the chat once. Okay, cool. So before we proceed towards the code, any doubts? Any doubt, irrelevant of it, any industry related doubt, any doubt about how do you want to start with the classification task, anything at all? Could you tell more about data mining? Sure. So data mining, basically it's the process of getting better patterns in data. Getting better patterns mean, for example, as the first two questions which I already told from an MBA point of view, I need to know what exact time a fraud transaction might occur tomorrow. I really need to know what amount of that transaction mean. So I just can't shoot arrows into air, right? I need to know exactly from my data at what particular time it is going to happen, or at what particular amount it is supposed to be happening, and the probability of it should be very high that it's a fraud transaction. Now, in terms of data mining, we really need to find the unusual patterns in our daily life, right? So if I actually manage to find a pattern that yes, fraud transaction occur in so and so amount range only. This is a very unusual pattern, right? So we'll be covering that part also. At the same time, if I actually get to know that yes, fraud amount transactions actually happen at this particular time, that's also an unusual pattern. So when such unusual patterns actually occur in your data and you are able to identify it and produce it in terms of a visualized and well documented result. Again, I'm repeating, these two words are very important: visualized and well documented. Because if you are not able to show what you are actually making, there's no point to it. The company won't be able to understand. So I had briefly spent a lot of time, around 6 months, in a company, in a startup, and they used to work on document image processing similar to something like Mu Sigma, and they had more efficiency by the way than Mu Sigma as an organization. But the thing about them which actually made the startup hit was that they were actually able to interact with the client and capture exactly what they want, work on that cutting edge and move on. And when you are working on it, there is something called a crisp DM principle. Okay. So a crisp DM principle is an industry standard principle which you actually have to follow. Okay. So, and mostly everybody in our entire data science division actually follows that. So that's actually a very interesting topic, but it's completely different and out of the context over here. Probably I'll be taking it as a separate one. I'll just enlist those in the chat, and these are just, you can actually go and jump to more information about each phase of the process. This is how an industrial level data science model is produced, and we'll be actually covering this principle in our code also, if you can see. So let's begin with our code, and I'll actually guide through almost 3 to 4 of them, except for the deployment part in this. So let's see about credit card fraud detection. And the first principle, as I listed in the chat, is called business understanding. You need to really understand what your client expects out of you, right? So we understand from the data and from different researches that we gather, credit card fraud detection basically is a completely imbalanced class problem, since there are very few number of fraud transactions compared to a very large number of legitimate transactions. So most of the approaches which are built on such imbalanced data, it fails to produce results in real time at all. So this becomes problematic to me. And why it fails to produce, again, which I kept on repeating, there is a bias towards the majority class. Majority class means something like legitimate transactions, which are in a very large number compared to the fraud transaction, which is in a very small number. So the business understanding, again, we take these 3 questions. What does the credit card frauds usually take place? What are the different trends of amounts, and how do we balance that data? For that, we will be trying with different algorithms. I'll not be explaining all this algorithm, but something which I included in this was how to make a pipeline out of all of these. That means to compare it. If you can see, I have also imported something called pipeline, and I'll be exactly making a pipeline of each of these algorithms and implementing it in this entire scenario. So let's move on. Now, the second point in a crisp GM approach is data understanding. We need to really understand what our data is. So if you can see, I have already run the data frame. In this, I hope everybody is fairly, even a beginner with Python might be able to understand. If not, I'll try to explain it a little bit in more detail, but I'll be jumping in more sort of due to lack of time. So in Python, basically we have pandas, NumPy, which are the core essence libraries for machine learning. People talk about TensorFlow, Keras. Yes, they are there as well, but on a very simple deployment level, nobody as an organization tries to complicate their tech stack unless it is absolutely necessary. I'm not saying people don't use it. I'm just saying they try to avoid unless it is completely necessary. For example, during my internship, I was told you're not allowed to use TensorFlow to make neural networks. So that's quite a surprise, right? But you have to make it in NumPy from scratch so that it actually runs more better. So the main libraries are pandas and NumPy. These are basically maths libraries and statistics libraries. So in our data, you can see that there are 32 different features from V1 to V28 and amount, class, time, as well as an index column. So why these features are named from V1 to V28, they don't have name, is because Kaggle says that for confidentiality reason, they had hidden their names. Anyway, they gave us more than likely what we need. They gave us time. What time does that fraud transaction takes place? How much is the amount of the fraud transaction taking place? And class is the final target label. So the first step will be, we need to identify what are our input set of instances. That means what is in the input data and what is the target variable, or rather what is the class label which we need to give, right? So there are, as I said, 32 features from V1 to V28, and the target variable is class. So basically the idea is that, boss, we will take from time till amount all these columns as input to our machine learning model, and our machine learning model will predict class as the final output, and we will compare it with the actual classes which are shown in the data frame and see whether our model is actually predicting the fraud transactions correctly or not. In our case, class 1 means fraud transaction and class 0 means legitimate transaction. Okay. So as you can see in the normal data set also, almost everything shows 0, which means it's a legitimate transaction. But there are fraud transaction as well, don't worry. So now the next step is, of course, data preparation. So in data preparation, we need to first of all identify different things. This is the most time consuming phase compared to other phases, right? And why this is the most time consuming phase? Because if your data isn't clean, there is a very simple principle which people tell in the industry: garbage in gives garbage out. So if we actually give shitty data to the model, it will give shit out back to you. So you can't really expect result to be a garbage towards your manager. So you really need to clean your data, standardize it, make it beautiful, make it readable, and then you need to process it using machine learning algorithms. So machine learning algorithms, as you can see, and I'm again re-emphasizing on the fact, it's actually the last part of this entire workshop, entire idea. The major crux is that you need to be able to identify features, ask the correct set of questions, and be very thorough with your maths in terms